Okay, this is problem set 7. So I'm going to work through some of the programs here. Actually, I'm going to work through all the programs here just to make sure you can check up with what you've done. Okay. Again, the homework I tend to grade, did you make a reasonable effort rather than is it absolutely correct? So hopefully by looking at the videos, you can figure out where you made a mistake if you did. Okay. So with this one, I'm going to start here, and that should be a T of C. It's that function that we can move over. Take off the caps lock. Okay. Those ideally are in italics, which seems to, there we go. Okay. So with this one, this is using the enhanced searching techniques we've talked about. So we have to build the shift table first. Okay. So that's the first step here. So it's pretty straightforward for letters that are not in our pattern. I didn't put this in here. The pattern is B, A. Keyboard is going insane. B, A, O, B, A, B. Okay. So this is the pattern we're looking for. Okay. So, and then the text is down here. This is our text that we're searching with. Okay. So again, when we were doing just the brute force sequential searching, we would just have to search everywhere. We would put the B, caps lock back on, B, A, O, B, A, B up against this and start looking, and it's not correct. So we would then move it over one time. Okay, so it would look more or less like this, like that, then like that, so forth. Okay, so that's the general idea if we're not doing any enhancement. Right? This is what this is about, doing the enhancements. Okay, so we go back to where we were. Okay, we will start that there as well. Okay, so anyway, for this pattern, if it's a letter that does not appear in the pattern, okay, then it's going to be the maximum. We can move all the way over. Okay, so for example, here when it's lined up against this K, there's no K in the baobab, whatever that is. Okay, so I know that this space, this whole column, if you will, can never be part of this. Okay, so I can move it over to there to start. Okay, so that means that everything that's not in the pattern is going to be a 6 because there's 6 letters. Okay, so in this case, A and B are in the pattern, but 6 is not. C is not. C is not. D is not. In fact, all the way from D to O is not. Okay, so nothing between O and Z, and that's the period, and that's the underscore. Okay, maybe a little hard to read. Hopefully it's not. Okay, I'll make it smaller if it's easier to read. Maybe so. Hopefully that will help. Okay, so then we have to worry about the things that are in the pattern. There's nothing here. This just should be blank. Okay, when we look at the A, okay, to get to the A, we have to move over 1 to get to that. Okay, so there's a 1 there. Okay. The B, it's not this B we're talking about. Okay, so if we're lined up with this B, we know it's had a problem somewhere else. We have to move over to the next B. So it's 1, 2, pattern to move over to the next B. Okay. Again, the C, the D, all that. It doesn't matter that the B appears and the A appear again because we can't move over to those because that may not be correct. Okay. The O, again, we're here. So to get to the O, it's going to be 1, 2, 3. There's a 3 for the O. Okay. And that's our pattern. So we start, again, we place the pattern against the left, and we look at this rightmost point here, okay, and say, you know, how does this match up in our shift table? Okay. This is our shift table over here. Still no caps, sadly. Okay. So K would be in here. We don't have a K, but K would be a 6. Okay, which means I can copy this entire pattern, move it all the way to there. Okay. Now I'll look at the B and the B. That looks good. I look at the A and the A. That looks good. Okay, but now this is not good. Okay, this is not correct. Okay, so since this B could be this B, okay, all I can do is move things 2 spaces. because B in the table points to 2. Okay, so now we're there. Okay, so now I look at the B against the U. It's automatically wrong. Okay, and I can in fact move it all the way to there. Okay, so we're now with a B with a B. That's okay. A with a 0 is not okay. Okay, so again, we can move it 2 spaces to there. Okay. Again, a B with a B, we're good. An A with an A, we're good. A B with a B, we're good. The O is there, the A is there, and the B is there. Okay. We figured it out. Okay, so this is where it needs to be. That's all we had to do to get there. Okay. So yeah, that's how that problem works. Okay. So for the second problem, it gives us the following alphabet. So I can again just copy the basic outline of this, and we'll rearrange as necessary. Okay, so in problem 2, our pattern, we can have an A, a C, no, sorry. The pattern is, we've got a different pattern here. Pattern is T, leave my all caps on again. Pattern is T, C, C, T, A, T, T, C, T, T. That's our pattern, okay? With a really big alphabet, okay? So all we can have in our, on the alphabet there, so that's the pattern. It's gonna be the a C, a G, and a T, okay? Everything else is blanked out. So the text can only have these letters, these 4 letters here, okay? Correct, so let's look at these. Okay, so when we're at the T, to get to another T, we can only move 1, okay? Okay, so the T is a 1, okay? If we're at the A, let's go to the A, okay? The A, when we're lined up here, is 1, 2, 3, 4, 5. So there's a 5 there. Okay. The C from here, 1, 2. 2 there. Okay. And the G is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it doesn't exist at all. Okay. That was a trick question. It's a 10. Okay. Because it doesn't appear in the pattern. Okay. So if we see that, we can move the whole way. Okay. And then as far as the text goes, I'm not going to go through the whole example again, but the basic idea there is that you're going to go through and figure out how many comparisons that you have to make at each time. Okay, so we can start it off here. So our pattern starts off T, T, A, T, A, G, A, T, C, T, C, G. Okay. So again, we're going to start with the pattern against that left-hand side. Okay. And see what we need to do with it. Okay. So we start here by looking at the T and the T. Okay. Which is a match. So we look to here. This is not a match. So we look at our table and do a 1. Okay. So basically all we can do is we do 2 comparisons. We do shift 1. Okay. We now have a T looking at the C. Okay. And for that one, we can do a shift 2. I'm out of my pattern, or out of my text, but it is there. Okay. And you go on from there. It works the same way. Okay. So that's what it looks like. Those are the 2 problems from chapter 7. Okay. So, sorry, section 7.2. Okay. So we can then move on to the next section, which is 7.3. Okay. And 7.3 is going to ask us to think about hashing. Okay, so again, the idea behind hashing is that we're going to have some formula that's going to give us a key that we can put into a hash table. Okay. So problem 1 there asks us to, we have the input 30, 20, 56. So let me, to make it a little simpler, I'm still going to use this for this one. We may want to switch to something else eventually, but for right now, this is fine. Okay. So we have the following things we want to input. So we've got 30, we've got 20, we've got 56, we've got 75, we've got 31, and we've got 19. Okay. And our hash function basically is going to do a mod 11. Okay. So our H, okay, it's going to take each of these, and I'm going to go ahead and pre-calculate these again because I'm doing it in Excel. So if I do a mod function, I take the number which I want, which is this key, and then the divisor is 11. Okay, which should give us all these values, right? And that's a quick way to do that. So we have a 9, 8, 9, 1, 9, 9, 8. Okay. So this becomes our, okay, so again, it's a little simpler. K and HK are there. Okay. And that's a little table as well. So I can format that. I don't see where that option seemed to have gone away. That's interesting. It was there. Now it's gone. There we go. Okay, so we've got that. Now I'll make it smaller again. It's probably messing with the video. Sorry about that. Okay, so now we have to go to store this. Okay, and when we store this, the way we're going to do it. Okay, so our hash table then is going to have 11 elements in it. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we're gonna have several iterations here where we're storing things. I'm gonna go ahead and put that out there. Again, make that bigger so I can do that. Okay. And the problem says to construct the open hash table. Okay. So this means the open hash table is going to be implemented with linked lists. Okay, so we have our keys here: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and the first 30, we place it first. It's going to go in the 8th position, so it goes here. Okay, the next thing we put is a 20 in the 9 position. It goes there. Okay. The next thing we do is a 56 in the 1 position. Okay, so that goes there. And these are linked lists. I'm putting it like it's an array, but it's not. Okay. We then do a 75 also at the 9 position. Okay, so that's got to go 1 layer down, 75 there. Okay. We put the 31 also at the 9 position. So that's now a 3-node linked list. Okay. And finally, we put a 19 at the 8th position. So it's going to go right there. Okay. So again, these are linked lists from there. Okay. So the largest number of key comparisons in this table. Okay. So when we're searching for anything, and we can do this just by counting up. Okay. So we have all of these things. Okay. So I can copy these again. Just over to here. And we're doing for a search here. To do the 30, okay, it just takes 1 search, right? I just go to there, boom, 1, okay? Number of comparisons, 1 comparison. The 20 has 1 comparison, okay? 56 has 1 comparison. The 75 has two comparisons. I find here and then there. Again, you just see the top row of things. Two comparisons there. The 31 is 1, 2, 3 comparisons. And the 19 is 1, 2 comparisons. Okay. Which is going to give you the maximum is at 31, and there are 3. Okay. And then for the average number of the search, for a successful search, we just have to basically go through and get an average of all the times here. Okay, so I get an average, again, using Excel. So if you did your homework in Excel, which is good. And it gets a 2, but that's probably actually, yeah, 1.667 or 1.7 is close enough on that. Okay, so that's the average, assuming that every key is likely. Okay, so that's what problem 1 looks like. So now problem 2 has the same information. Okay, so we still get the exact same, all this is the same. Our K and our HK are exactly as they were before. Okay, but this time we're going to use the other method. Okay, so this is going to be the closed hash table. Okay, so I can go ahead. We don't have the linked list, so we're going to get rid of this stuff. And we're going to calculate this one this way. Okay, so we do the 30 first. The 30 goes to 8 here. Okay, 20 goes there as before. Life's good. Okay, and the way that the answer guide gives it makes some sense. It just shows at each step what we're adding. Okay, so at this point we have the 30 and we have the 20. Okay, so we're going to get 6 30s here eventually. So I can go ahead and copy these down. Okay, it's going to be here as well. Okay. So the third thing we add is a 56 at 1. Okay, which we'll add down here. Okay, and that will stay there, showing the state as that changes. Okay, the first trouble comes here when we try to add the 75. Okay, into 9. We go to 9, and I guess we're at this level now. Okay, we go to 9. There's already something there, so we have to move 1 over, put the 75 there. Okay, and that will continue on down. That fills that space forever. Okay, we're now to this next row here. We're trying to place the 31, which also goes to a 9. Okay, so because things wrap around, the 31 should go to the 9, which is here. It can't. So we try here. We can't. We go all the way over. Oh, these are wrong. These are actually at 1. I had them at 0. So let me move these correctly to there. Okay, and now get the formatting back. Okay, so now when I try to put this one, again, start back over here. I try to put 31 here. I can't. I try there. I can't. I go all the way back over to here. I can now put 31 there. Okay, so the last one is a 19 that should go at 8. So I try there. Nope. There. Nope. There. Nope. There's still 31 here. Nope. Nope. All the way over to there. Okay, we can then do the same thing we did before and figure out the time it takes to get to each of these. Okay, so again, I can get to, and this at the bottom is really what we have. Okay, if I look for a 30, I look in this position and I'm good. That's a 1. If I look for a 20 and a 9, that's a 1 too. Okay, so we still have the 1 and the 1 there. The 56, when I'm looking for it, okay, it says to go to 1, and I do, so we're at a 1, so we're good. Okay, 1 goes there. 75, it says go to the 9. I go to the 9, and it's not there. So that's 1 comparison, 2 comparisons there. Okay, so we have 2 comparison there. The 31, it says go to the 9. Okay, I go here, it's not there. So I have to do 1 comparison, 2, 3 comparisons. Okay, so the 31 has 3 comparisons. Okay, and then the 19, it says it should be at 8. So I do a comparison there. 1, 2, 3, 4, 5, 6. It's pretty bad, right? That gets us to a 6. And our average then for this is going to be a 2.3. Okay. So in this example, it's significantly worse. And that is in general going to be the case. Okay. Okay, so sorry, got a phone call there. So let me. Okay, sorry about that. So that was that answer. Okay. So that gets us down to the B tree problem. So I think it makes sense for me to switch to the whiteboard. So let me do that real quick. Okay, I'm not sure this is the grandest way to do this. So let me see if we can work through this one. So we're trying to, again, if I draw the first row here of this B tree, we have the 20 here. Some of you use Excel for this, and that may not be the worst thing in the world, but we'll see. Got the 51, and there's one more we could have. Okay, so there are 3 possibilities for each of these, okay? So with the 30 we're going to add, okay? We know from here, it's going to be between the 20 and the 51, okay? So we're gonna add it this way, okay? So it goes to the secondary node, currently has a 25 here, a 34 there, and a 40 there. Okay. So the 30 that we're trying to add is going to go between, okay, in the leaf here. Okay, so the 30 is between the 24 or 25 and the 34. Okay, so this is going to go down to our leaf node. Okay, and the leaf node we can add in. We can have 3 values here. Okay, so we can add a 25, which was there. We can add a 28, which was there. And we can add our 30 right here. Okay, and it's still good. Okay, so if we go to add 31, okay, we now have some more complexity here. Okay, it's because there's no room. The 31 would need to be in this one here. Okay, and it can't be. Okay, so to do this, we're gonna have to rearrange things around some. Okay, we're gonna have to split the leaf and then split the parents. Okay, and we've got the room to do this because there's currently nothing in the, we can split the parent and we're going to have a better thing here. Okay, so I'm guessing the best way to do this, okay, so we're going to change this. Doing it with the mouse is not the best way to go. Okay, so we're still going to have the 20 to 51 is not going to change. Okay, but we're going to have to switch this one to be a 25, a 34, and a 51. Okay, so then it's going to go down between, sorry, it's a 20 and a 34. These are hard to deal with just because they're so big. Okay, a 20, 34, 51. Gotcha. That makes sense. Okay, so between the 20 and the 34, okay, this is, I'm in the wrong thing. Let me start over again. Let's just start the whole thing over. Okay. Yeah, that's too, look, I'm going to switch to something else. That was a difficult, the first one wasn't too bad. For this other one, it's going to be more difficult. Okay, so let me stop the share. Let's go back to Excel. Let's see why people did that now. Sorry, that was so confusing. Okay, so let's get rid of all this stuff, but we can use this area. Should be able to. So we should be able to clear the formatting here. Well, let me clear all that stuff. Clear contents didn't work. It didn't work. So let's just hard code it. Sorry, it feels like a Monday, but it's not. It's a Thursday. So we want we want no border. There we go. Okay. Mental note, think about how you're going to present things before you present them. Okay, so again, on this one, we've got in the first row here, the 20, we've got the 34, we've got the 51. Okay. From that, the first index over here is going to have an 11 and a 15. We didn't mess with those at all. Okay. We've had to split these now. Okay. We've had to add stuff to this. Okay. We've had to add the 34 up this way. And the second one's going to have a 25 and a 30. Okay. Over here, we have the 34 and the 40. Okay. We're going to put the 60 over here by itself. Okay. These are still the interim nodes. Okay. And the ones we care about here are off the end of the 25. Okay. We're going to get the 20 and the 24. Okay. Between the 25 and 30, we're going to get the 25 and the 28. Okay. And then to the right of the 30, and this is really hard to see on here, we're going to get the 30 and the 31. Okay. So I guess these are really past that. Okay. So this is to the left of the 25. This is between the 25 and the 30. And this is to the right of the 30. Okay. Then the next one of the 34 and 40, to the left of the 34 and 40, we get the 34 and the 38. Okay. Between the 35 and the 40, we get the 40, the 43, and the 46. Okay. And then over here off of the 60, the left one gives us the 51 and the 55. And the right one, I don't have, well, I guess I have the space. It gives me a 60, a 68, and an 80. Okay. So that is a not very satisfying way to draw that, but hopefully that gives you the idea. Okay. So that's the solutions for this particular problem set. If you have questions about that, make sure that you let me know.